Assalamualaikum and very good evening to you, my panelists. Today, I'm going to present about my FYP project design and development of a low-cost portable indoor air quality monitoring device for industrial environment. My name is Achmed Ammar bin Nordin and my matric number is B0717102255. This project is supervised by TS Dr. Muhammad Haider bin Mazlan. Okay, there are 7 things to present today, which is introduction, objective, scope, literature review, methodology, result, conclusion, and recommendation. Okay, this is my introduction. Air emissions are often harmful to the atmosphere and to human health. Environmental pollution is defined as an air condition in which certain contaminants are successfully likely to have a significant effect on human and animals, plants, or material above their natural ambient levels. To monitor air quality is very important because it can have direct consequences for human health and the environment. What is Arduino? Arduino is an open source platform used for building electronic projects. Secondly, Arduino consists of both a physical programmable circuit board used to write and upload computer code to the physical board. Okay, this is my background. IAQ is indoor air quality. Air quality of a particular room or building that is concerning about its own climate. IAQ is very important for human to do activities. Okay, this is my problem statement. Rapid development in industry, especially in the urban civilization, leads to the environmental pollution. This is my objective project to successfully propose and produce an efficient and effective device unit for indoor air quality IAQ. And my second objective is to research and develop a easy and cost-effective indoor air quality. Okay, this is my project scope. Primarily aimed at studying and developing a prototype of an indoor air quality device unit IAQ with the core system established can be defined as the system integration of an Arduino circuit linked together to several sensors. Okay, this is my literature review. Okay, this is data for temperature and humidity. Okay, firstly, temperature has to be maintained between 18 to 33 degrees Celsius. Okay, this means that temperature around us must be around 30 to 35 because it is a normal temperature we have to live on. Okay. Secondly is humidity range is 40% at 60%. Okay, the normal humidity value must be around 55 to 60% to be comfort with. Okay, this is data gas sensor CO2. Ventilation rates should keep carbon dioxide concentration below 1000 ppm to create indoor air quality condition acceptable to most individuals. Okay, what if the value above 1000 ppm that will cause the hazard to our health and also to our environment. Okay, this is my comparison for previous system. There are many previous system. There are many previous system that has been created for this Arduino IAQ, such as microcontroller, display monitor, interface, type on sensor. Okay, this is the list of the previous device that has been created. Uh, firstly is they are using Arduino Mega 2560 and display monitor, Android, Bluetooth and computer. And type of sensor, sharp dust optical sensor, MQ9 gas sensor, MQ135 gas sensor. Okay, this is my methodology. My methodology begin with planning, research, design, implement, and analysis. Okay, what is planning? Planning is, I'm going to tell you what is planning. Planning is about to create a project and also research and design, implement, and analysis. Okay, this is my flow chart, which is start and project planning, choosing a title, research and data collection, title evaluation accepted. If no, if we're going back to project planning or choose a title. If the title is accepted, we are going to identify the objective and literature review and do the methodology. And then is compare and analyze review and methodology. And lastly is planning on hardware and software. Okay, my second flowchart is develop software and design on hardware. Test if the software and hardware working. If no, we are going back to develop software and design on hardware. If yes, analyze the data and do the discussion and also the conclusion and recommendation. Okay, this is the purpose. This is my component used in this project, which is Arduino Uno, the uh, the DHT11 sensor, the MQ135 sensor, and the PMS 5003 sensor. Okay, the DHT11 is the temperature and humidity sensor, and MQ135 is gas sensor, and PMS 5003 is the PM2.5 and 10 sensor. Okay, this is my circuit for DHT11 sensor, which is the red line is going to the red line is going to the 5V, which is the power supply, and the black line is going to the ground, and the blue line from the Arduino number 1 pin is going to the data pin in the temperature humidity sensor. Okay, this is MQ135 sensor. Okay, this is the circuit of the MQ135 sensor, which is the red line is going to the power supply pin in the Arduino Uno, and the black line is going to the ground from the pin ground to the pin of the sensor, and from the pin of the Arduino is A1 going to the data pin at the DHT11 sensor. Okay, this is the circuit of PMS 5003 sensor. The red line is the power supply from the Arduino board 5V pin going to the VCC pin. And secondly is the blue line. Blue line is the ground from the pin in the Arduino Uno. The blue line going to the ground pin at the sensor. Okay, yellow line is RX, which is from the Arduino Uno. The number of the pin is 6 and is going to the PMS 5003 sensor. And also the number 7 pin is TX. Okay, this is the photo of the hardware circuit. From the circuit that has been created or from the circuit that has been created or getting from the internet that has been implemented on this breadboard. Okay, this is my result. Okay, firstly, I'm going to talk about the low cost. Okay, there are 5 items that has been bought from the online platform and store. Okay, firstly, my cost for Arduino Uno is RM24 ringgit, and my MQ135 gas sensor is 8 and 50 cent, and my PMS 5003 is 50 ringgit, and DHT's 11 temperature and humidity sensor is 6 ringgit, and LCD screen is 3 ringgit. So the total for this project is calculated for 92 ringgit. Okay, this is this is this is this has achieved our objective, which is low cost device. Okay, this is my software testing. Arduino. I'm using Arduino IDE software. In this software, we can create we can create uh, we can create a coding to command our sensor from Arduino that has Okay, this is my software testing. I am using Arduino IDE software. In this software, we can create command and or coding to command our sensor that has been linked to Arduino Uno board. Okay, in this software, okay, as you can see, the picture number one is my coding that I want to test it, and the second picture is the data that has been collected from the COM6. This show that my project is this show that my project is successfully being tested. Okay, this is my result at workshop one, where that I have been collected. Okay, for the number one, the temperature is 33 degrees Celsius, and for the humidity is 60%, and the PM 2.5 and PM 10 is 60, and the PM 10 is 155. And also the air quality is 150. Okay, from uh, overall, this result is acceptable because the PM 2.5 and PM 10 is moderate, which is it will not cause hazard to our health. Okay, this is result at workshop 2. The temperature at result workshop 2 is 33 and the humidity is 60%. PM 2.5 68, PM 10 is 155. Okay, the air quality is 153, which is unhealthy for sensitive group. Okay, the meaning of unhealthy for sensitive group is the sensitive group stands for the kids or human that has asthma or breathing problem. Okay, overall, this result at workshop 1 and workshop 2 is accepted because it cannot cause our health. It cannot cause hazard to our health. Okay, this is outdoor analysis. Okay, for this outdoor analysis is a benchmark to my project because whether my project is successfully being done or my project is failed. Okay, this show that my project has been successfully done because this is the normal reading for outdoor analysis. Okay, for this reading, there are three reading that has been taken. Okay, for temperature and humidity, this is all the normal temperature. And PM 2.5 and PM 10 is the normal value. And and we can live with we can live without worries. And the air quality for this three reading is normal. Okay, this is hardware testing. Hardware testing at workshop 1 and workshop 2. Okay, for conclusion, this project has been successfully met its objective with the main reason, a low-cost air quality monitoring device. Okay, this is my recommendation for the future research purpose, which is number one is adding the memory card slot to save the data from previous tests, and also adding the Wi-Fi module, and also adding the Wi-Fi module to take the data from a phone. Okay, that's all from my presentation. Thank you.